And we'll talk through the features. Exciting stuff. It means we learned something, right? Going to activity 4.2 in the book. You need to use the restroom. Well, let's finish going over this and I'll let you go. Alright, so which features of a parabola can we quickly see in vertex form? Vertex, concavity, and the line or axis of symmetry. What is the line or axis of symmetry? The whole line. So it's a vertical line, right? So x is equal to something. Remember, it has to go through the vertex. And what is the x value of the vertex? H. So x is equal to h. Right? The axis of symmetry is always x equals h because it has to go through that vertex. Alright? Vertex. Hopefully we all have it. The vertex is h. So h comma k. Remember, it's a single point, so we need to write it like that. What's the one thing we have to be careful about? The negatives and positives. Which one do we need the opposite with? H. But k is just whatever the sign is. Right? So we need to be careful with that. The h value is always the opposite of what we see there. Students mess that up all the time with roots. Well, you don't want to say negative h like that because notice it's x minus h, and so we have a positive h there. So you don't want to. You might want to make the notice the opposite of what's in the parentheses, but okay. And then concavity. It's the same. Right? So you can rewrite it if you want, or you can just say if it's the same. If a is greater than 0, the parabola is concave. Concave. Up. Thank you. Okay. And if a is less than 0,
Down.
Concave down. All right. Could I find the x-intercepts and y-intercepts, you think? Yes. What do we have to do to find that x-intercept? Okay, so first off, we want to say substitute, not plug in, but the k, remember, we need to be careful, the k is only the y value of the vertex. But what should everyone know about every x-intercept that has ever existed? The y is 0, right? So we're going to substitute 0 in for y. And so 0 is equal to a times x minus h squared plus k. You actually already know how to solve this equation. Don't sweat it yet, though. We will cover that more in the next lesson that we start either Wednesday or Thursday. So 0 is equal to that. And so we would have to solve for x. So what about the y-intercept? Same thing, but when you say just opposite, you mean substitute 0 for x. Be clear with that language, right? So we're just going to say substitute 0 for x, right? So f of 0 is equal to a times 0 minus h squared plus k. And again, that's super algebraic, but I just mean substitute 0 in and then simplify from there. So you can find all of these features no matter what equation you are given, right? Now be careful and pay attention to the ones that are easy to find right away, but you can always find all of these features. get your x equals the average of those roots there, and then get your graph sent to. Collaborating pretty well there. See, I don't think it's cold. Sorry, y'all. Before we continue to the next part of this lesson, what are your questions? What? That nap?
It's not time.
Say again.
It's not time.
It's not nap time. I'll pray about it. Sorry you feel this way. Alright, so no questions about the math, so that means we're going to continue forward. No.
That's what you need. That's what you need in your class. A brain break.
Maybe
A
we'll
1 minute
go up.
brain. I agree. I agree with that opinion. My collaboration will go way up.
Just give us.
So at this point, when I look at 3B, don't sweat this one. I'm going to focus on number 4. Just make a note. What pages was that? M1-73, I think? Wait, we're going backwards, guys. We're going backwards to the beginning of the lesson. But those 73 to 75. So just see M1-73 to M1-75.
Which page are you writing on?
Oh yeah, sorry. 56 is where I'm writing this. My bad. This is page 56. But that number 4, we're just saying, hey, see M1-73 to 75. So that's where we did all of that work. Wait, 56. To take this note? Yep. Alright. So, you have all that information there. And 3B, explain the methods you used. Realistically, you just focused on which form you had. If you had vertex form, you looked at the what? The vertex and concavity. If you had factored form, you looked at the intercepts and the concavity, okay? So we're now going to apply this. You may want to refer back to those graphic organizers or to the Desmos activity. But here's the very next page, activity 4.2. I'm going to work through 1 or 2 of these with you. But with all of these problems, it just says analyze each graph. Then circle the functions, or the function or functions, which could model the graph and describe the reasoning used to either eliminate or choose each function. Notice how they have you practicing what with these questions? Starts with a J. Justification. What's your reason? You're going to make a claim. Now, what's your reason for it? So one of the things I want to point out is if I were to type this into a calculator, would it quickly give me a graph either similar to this or not similar to this? Yes. So do you think I'm going to allow you to use this on a graphing portion of an assessment?
Yes.
No. You will not. You will have questions like this. They will not be on the graphing portion of an or graphing calculator portion of the assessment because you can just plug that into a calculator. I want to know that you understand what that equation looks like. I don't want to know that you understand how to work a calculator. You can plug junk in. I want to see that you understand that equation. So, but here's the thing. This doesn't have to be hard. When I look at this, I'm asking, can f1 of x, or could this be the graph for f1 of x? So what should we notice about f1 of x right away? Okay, this graph is concave down. So a is less than 0, concave down. Cool. What else? 2x. It's factored form, so it's 2x. Intercepts. There we go. So, yep, roots. So what would the x-intercepts of those roots be? There's 0, -1, and 0, -4. Does anybody want to push back on or add on to that? That's right? Amari, you saying no? Why are you saying no? We need x-intercepts? Are you saying those aren't x-intercepts?
Did you mean to say we need y-intercepts?
Well, I mean, it's factored form. Which one do we need?
We need the x.
Ah, factored form is x-intercepts, right? Tristan? What do you mean by that? I put them in the wrong place.
Oh crap.
So like, are you trying to say like they should be switched like this? So like -1 comma 0
Yes.
and
The other way.
-4 comma 0. Remember, it's R1 comma 0 and R2 comma 0. And so I heard of several people actually saying this. We need to be careful. When the input is 0 or the x is 0, you have a y-intercept. We wanted a y value of 0. Okay? What are your questions about this so far?
So what's the answer? Hold on.
Okay? So the question, remember, is analyze each graph, then circle the functions which could model the graph. So could this equation, based on this information, go with this graph?
Yeah.
Okay, why?
Come on.
Come on, Mr. Kenny.
Because it's concave down and
Okay.
it's on the negative side.
What's on the negative side? The
Parabola. The
Yes.
U.
X-intercept.
x-intercepts, right. We have negative x-intercepts. So you're getting there, you're working on that language, and I do like it, but I do want you to notice, because people in first block were freaking out. They're like, but Mr. Kenny, there's no way that could be -1 and -4. Do we have a scale on that x-axis? No. All we know is that the x-intercepts have negative values. Do these x-intercepts have negative values? Yes. So F1 could go. Those features match. So let's look at F2 of x. So F1 of x works. Remember, and it says there could be multiple functions in the directions. So could F2 of x work? Why not? Does it have to be in factored form? No. What form do we have in F2 of x? We have standard form. What did you say, Chelsea? Didn't think of standard form? Notice though, ax squared plus bx plus c for F2 of x. Okay, that's what we're looking at here. So what features should I be able to see out of F2 of x? Y-intercept and concavity. Does the concavity match that graph?
Yes.
Concavity is good, right? A is less than 0, concave down. What would the y-intercept be? Standard form, does it switch? Does the
It's negative 6.
it's -6, but what's the point? So could that match that graph? Sure about that? Remember, there's arrows down here, right? So is it going to continue going down?
Yes.
Is it also going to continue to the right? So will it have a negative y-intercept?
It could possibly.
Yes. Not possibly, it will, right? It'll continue going down and continue going out. So there is a negative y-intercept. So does that work?
Yes.
And so be careful about that. It's just a negative versus positive idea on a lot of those things. And so we have to work through that. So please be aware, it doesn't have to be factored form. It doesn't have to be standard form. We're looking at those equations and saying, hey, based on the features that I see, could this equation work? And so like, you could even go beyond this with F2 because I have standard form. I could look at the x value of the vertex, right? So the opposite of b would be a +3 divided by 2 times -1/3. Just focusing, if I have a positive divided by a negative, that vertex would have a negative x value. Does this vertex have a negative x value? Yeah, that's negative in the x, right? So I haven't checked on it and substituted in, but that's something else I could notice. And I will point out, checking this, would that give greater evidence of your understanding?
Yes.
Remember on assessments, I'm looking for evidence of understanding. So looking for that vertex can also help. Okay? So let's get to work in our small groups the next 10 minutes, analyzing those different equations and asking, hey, could this equation match the graph? If not, mark it out and explain why. Justify your responses. Right, you made a claim. And 2 is what value in that equation.
I don't know how to
Right? You want to include that detail that the 2 is our A, so it's concave up. Also, that's saying that A is less than 0.
Excuse me?
You want the other direction. Remember, the bigger number goes with the bigger sign of the inequality.
This right here, is this the
I got you.
the x squared.
I just want to make sure I can catch that before we move forward.
No, so it's not. And what's this? Is this right here?
Well, so I was just trying to listen to what you said.
That would be y coordinate, y themselves.
Correct. So A is positive here, so that probably would be concave up. That doesn't match that. Yep. And there's other issues also, and at least one of them, I think there's another issue with F5 of X.
So,
I'm an positive
this is a person.
That was a supplemental sheet that we worked on last Thursday. So did y'all circle the equations that could go with the graph? So don't forget, look beyond just the concavity. Okay. Yes, ma'am.
So the A is always in front of the square.
A is the coefficient, whereas a coefficient. What's your rule question? Well, notice that's x minus 6 squared. That square would happen before the negative. So that negative is really just -1 representing my a. So that's not going to affect what's inside of here. A is A, and that's it. So A is just negative. So what is that going to affect in the equation? Right.
Not the same equation.
They're very similar. There's a huge difference that works. In fact, only one of them would work for that graph and the other one would not. Would 3 be the y-intercept? What form do you have in F6? Then you might want to look at this or look at your other notes. What form do we have in F6 of X? Standard form. Does that look like the A times x minus h squared plus k? So we have vertex form, which means we should be looking at the vertex. What's the vertex for F6 of X? It's what? Here's my vertex form, right? Vertex is h comma k, right? What's my h in that equation? Remember, it's x minus h. So to get x minus 6, h had to be positive or negative.
I love that dollar penny. Did you know that? You should put it up to me.
Is that h positive or negative 6? positive 6. So the x value of that vertex would be 6. What's the y value of the vertex? 3. Remember, with the x values, we always need the opposite. Could that vertex go with that graph? No, because that would be to the right. We don't have that. Hey guys. It could be right if there's factor form. Maybe not that one, but factor form can work. Okay. All right.
Thank you.
We got a couple of minutes left. Let's check our answers. Which one could, or which of these do we need to ask questions about? Okay, we'll talk about all of them. Elliot, look at Schoology. There is a small homework assignment, or get it from someone in here. Okay, they'll be due on Wednesday. Yes. F4. Okay, so if I look at F4 of x, it's equal to 2x squared minus 8.9. What form is that in? It's not vertex. It could be vertex. I hadn't thought about it that way. I was thinking standard form. Okay, hold on, look. Right here, this is y. Okay, hold on. It could have been a 0 for the b, so 0x. It could be factored form if you treat it as x minus 0 squared. Not any, it could not be factored form. Okay, so it could be that. Regardless though, can anyone tell us why equation 4 would not work for that graph? Concavity right away. A is greater than 0, so that graph would be concave up, which would not match that graph. Okay, which of these other ones do we need to ask questions about? The last one? Okay. I don't know why I hear anyone packing. We got 2.5 minutes left. And I know you're not robbing me of my teaching time and robbing you of your learning time. So, when I look at this, yes ma'am? No, no one asked about it. We can in a second. But looking at number 8, the last one, which form is this? Vertex. So right away, I want to think about my concavity and the vertex. So what's the concavity? Down. A is negative, so it's down like a frown. And what would the vertex be? Remember, to get x plus 6, I had to subtract a negative 6, right? The only way to get x plus 6 is if we were subtracting a negative 6. And one thing, if you haven't noticed, I hope you start to notice, the x value goes with x. The x value goes with x. You compare this with, again, with the idea of point slope, x minus x1 plus y1, right? X and y. But then what's the y value of the vertex? 3. Notice the y value never is the opposite. Is that to the left and up 3? Or to the left and up? Yes. So that's why 8 would work. Jordan, do you have a question about 7 quickly? You good? Okay. All right. Last couple of quick notes. So, please note that there is a homework assignment that is due on Wednesday. It is only 2 questions from Module 1, Topic 1, Lesson 3. We'll definitely say this, it's up there, what page. I feel like there's definitely been some good learning today. I know some of us still have to work on this, and that's okay. But what are all of you? Capable of more. Wednesday, at the beginning of class, we're probably going to have that understanding check. Be aware and look for that. It'll be probably the beginning. I didn't lie. I didn't remember how many parts there were.
No, not.
Get an attitude. Come on with it. That's true.
Logan, dude, I just saw you on camera.
It's time to go. It's time to go home.
Have a nice day, Mr.
You too.
I have to finish writing my note report. So everybody doesn't forget it. Oh.
Good afternoon, Nathan. Yes, sir.